Welcome to The Explainer. Today, we're taking a fascinating journey from agricultural waste straight to global textile innovation. We're looking at pineapple leaf fiber, or PALF for short. It's wild to think about, but a simple byproduct of the fruit industry is literally reshaping the future of sustainable fashion and industrial materials.
Before we map out our journey today, just consider this. Can a discarded fruit leaf actually replace synthetic leather and toxic plastics? Think about waste valorization. That's the process of taking things we'd normally just throw in the trash and giving them real economic value. It can entirely shift a farming model into a heavy-hitting industrial engine. And today, we're going to see exactly how that happens.
So here's how we're breaking it all down. First up, the pineapple fiber revolution. Then, processing leaves into raw fiber. Third, engineering the spun yarn. Fourth, performance and fiber blending. And finally, the future of eco-textiles. Let's get right into it.
Section 1. The Pineapple Fiber Revolution. From 17th century craft to modern solution. The history of this fiber is actually a pretty wild ride. Back in the 17th century, Spanish settlers introduced the pineapple to the Philippines. The locals there quickly figured out how to extract this incredibly delicate, lustrous fiber known as piña. It was gorgeous. In fact, it became so prestigious that in 1850, Queen Victoria was actually gifted a piña petticoat. But, then the Industrial Revolution hit, cheap, mass-produced cotton totally flooded the market, and the slow, painstaking hand extraction of pineapple fiber, it just couldn't compete. But, fast forward to 1996, piña makes this massive comeback on the world stage when global leaders wore it at the APEC summit. And that brings us up to speed. In 2024, producers in Vietnam hit a staggering milestone, cranking out 18 tons per month. Talk about an explosive modern resurgence. Now, looking at the industrial viability, it's really a balancing act. On one hand, you've got incredible strengths. We're talking 10 times the tensile strength of cotton, natural UV50+ protection, and it's even naturally antibacterial. No way, right? But there are weaknesses. It's naturally very stiff, and the historical cost of extracting it by hand is just way too high. The opportunities here, though, are absolutely massive, specifically replacing toxic PVC and silk. But to actually pull that off, the industry has to tackle the high capital costs for automated extraction machinery, plus fend off competition from dirt-cheap synthetics.
But here is the absolutely crucial takeaway, the real environmental math. For years after harvesting pineapples, all those leftover leaves were just treated as trash. Farmers would just burn them, releasing tons of carbon into the air. By stopping that burning and turning the waste into textiles, like Biodegradable, we get a massive win. Literally every single linear meter prevents 12 kilograms of CO2 from hitting our atmosphere. 12 kilograms. It is a complete paradigm shift from a wasteful model straight into a true circular economy.
Section 2. Processing leaves into raw fiber, the mechanical and biological sequence.
Okay, so how do we actually do it? The sequence is a huge leap from manual scraping to modern, efficient systems. First, you collect the leaves and run them through semi-automatic Citra decorticators. These machines use this alternating beating and scratching motion that kicks out up to 80 kilograms of fiber per shift. That is a massive upgrade over doing it by hand. Then, the fiber is washed, dried, and mechanically fluffed for purification. If we're making non-woven textiles, it gets mixed with a corn-based PLA to create piña felt, finished up with eco-friendly GOTS-certified pigments, and shipped out. It's a highly engineered 8-step gauntlet.
But right in the middle of that process is a major technical roadblock called degumming. Raw pineapple fiber is packed with about 30% gummy matter, stuff like lignin and pectins. If you don't biologically or chemically strip that gum away, the fiber stays at a really coarse 25 to 35 denier. That's just way too thick and brittle to ever spin into yarn. Degumming slims it all the way down to a smooth, spinnable 12 to 20 denier. It's literally the make or break step for making apparel-grade fabrics. Section 3. Engineering the spun yarn. Adapting the cotton spinning system. Now we hit the magic key to unlocking the traditional clothing market, cottonization. Standard cotton spinning machines are built for really short, soft fibers. But pineapple leaves? They produce super long fibers. So cottonization is the process of physically cutting and refining those long leaf fibers into exact staple lengths of 30 to 40 millimeters. It sounds simple, but it's brilliant. It's what moves the whole industry from just making stiff, non-woven felt to actually producing those soft, draping spun yarns that clothing brands use today.
Getting that to work, though, takes some serious mechanical tweaking, like the workarounds discovered by Art University. You can't just toss pineapple fiber into a cotton machine and hope for the best. The yarn will literally just snap. For instance, they had to double the size of the draw frame trumpets from a standard 3.5 millimeters up to 7 millimeters just to fit the fiber through. They also have to strictly cap the carding cylinder speeds at 300 RPM. Otherwise, the coarse fibers tangle up into tiny knots called neps. It's such a cool example of adapting existing factory infrastructure for a brand new, sustainable material.
But even with wider machines and slower speeds, the fiber itself needs a little extra help. See, unlike sheep's wool or cotton, pineapple fiber doesn't have any natural crimp to it. It's completely straight and stiff. Drafting those stiff fibers into fine yarn counts would be pretty much impossible without a very specific surface treatment, exactly 5 grams per liter of silicone softener. That softener literally lets the individual fibers slide smoothly past each other during the drafting process without breaking. Section 4. Performance and fiber blending. 100% PALF versus strategic blends. So pure 100% pineapple yarn is incredibly strong, and it has this highly breathable moisture regain of up to 12%. But its elasticity is really low. It barely stretches at all, which means it's really only good for stiff, structured woven fabrics. If you want comfortable, everyday clothing, you absolutely have to blend it. Hitting a 30-70 ratio of pineapple to cotton is basically the sweet spot. It perfectly balances the structural strength of the leaf with that soft commercial feel of traditional cotton. To really get why these specific blends are so amazing, scientists actually used highly advanced synchrotron radiation X-ray tomographic microscopy. Try saying that 3 times fast. But seriously, it's an incredibly powerful tool that lets them look deep inside the microscopic structure of the yarn while it's actually being spun. And what those X-rays revealed is absolutely fascinating. It's called the index of blend irregularity. Basically, the physics of the spinning machine naturally force the stiffer pineapple fibers to migrate right to the outside edge of the yarn. Meanwhile, the softer cotton fibers naturally settle down safely into the core. So what do you get? A fabric that has the stability and cozy softness of cotton on the inside, but the outside has this gorgeous, lustrous, slightly hairy aesthetic from the pineapple fiber. You're literally getting the best of both worlds engineered at a microscopic level. Section 5. The future of eco-textiles. Commercial scale and end uses.
Because it's so incredibly strong, naturally antibacterial, and controls odor, this stuff is incredibly versatile. In fashion, brands are using it for sustainable denim and performance wear. In home design, it's literally being used right now for luxury upholstery at spots like the Hilton Hotel Bankside. And it's so rugged that in the industrial sector, they're using it for heavy-duty marine cordage and even mixing it into reinforced roofing sheets to make cement stronger. Seriously, how cool is that?
And this revolution is scaling up fast. Ananas Anam is bridging the UK and the Philippines to lead global R&D. Over in Manipur, India, regional cooperatives are preserving breathtaking, ultra-fine hand-weaving traditions. But the real heavy lifting, industrial shift, that's happening in Vietnam. Producers like Textile are scaling from 18 tons a month in 2024 to a massive target of 50 tons per month by 2025. With global ESG targets and the huge push for supply chain transparency, we are watching a boutique craft turn into a mainstream industrial staple in real time. Which brings us to the end of our explainer. As massive global brands scramble to decarbonize their supply chains and ditch toxic PVC synthetics, we really have to ask ourselves, is agricultural waste the ultimate blueprint for the future of sustainable innovation? It's a powerful thought to leave you with. By engineering a fully biodegradable, totally traceable material out of leaves that farmers quite literally used to set on fire, we might just be looking at the absolute future of the global textile industry. It is human ingenuity solving ecological crises at its finest. Thanks so much for joining me on this deep dive, and keep asking the big questions.